The Firey Connection, Climate Change and the Escalation of Wildfires by Maddie, Marissa, Hayden, Morgan, Paige, and Ellie. I am now going to provide a little bit of background on this problem. As we may know, wildfires have become a lot more prevalent within the past decade. The extent of this recent surge is very unclear despite the $1 billion of federal firefighting expenditures that are being spent per year. These fires have caused many issues, including individuals losing their homes, everything in their homes, and a lot of people have even lost their lives. Although there is not much talk surrounding the cause of these issues, within the scientific and fire management communities, this discussion has increased in order to try to find an explanation as well as a solution to this issue.
The two main reasons for the increase in wildfire activity is climate change and land use. Climate change is increasing the temperature of the world and making the earth a lot drier. As global warming increases, the land is getting drier and warmer, which is perfect fire conditions. The wind is also getting a lot drier, so spreading the fire is very easy and it spreads very drastically. Land use is the other reason for an increase in wildfire activity. Land use is about how the human population is treating Earth. Forests are used mainly for agriculture and livestock, but that causes deforestation and it can dry out the vegetation. This makes the land dry as well and can cause the fires too. The differences between the two is how the warmth in the dry land is caused, but because land use and climate change both lead to warm and dry conditions, they're very similar as well.
The methods section of this presentation highlights the procedures used to collect the overall data in this study. The first method used was wildfire activity. This method allowed the audience to better understand the frequency and intensity at which the wildfires spread. The second was comparing the activity of the fires and the snow melting. This specific method measured how the wildfires spread / how long they lasted in comparison to how fast or slow the snow melted in the spring. Basically, the correlation between the two was observed and measured. If the snow melts earlier, are there more wildfires, but if it melts later, are there less? The third and final method was spatial variation versus the timing of spring. This method allows researchers to observe the differences between various wildfire locations across different regions in comparison to when spring fell. The authors used the timing and length of the wildfires to analyze their previous methods. They looked at when the wildfires typically begin by comparing the snow melting, earlier springs, and much more. Also, how long each of these fires would last. After the data was gathered and observed, the authors would then use these findings to come up with the results, which would be mentioned in the next part of the presentation.
The results show that wildfire activity has increased suddenly since the mid-1980s. This increase is due to higher wildfire frequency, longer wildfire durations, and longer wildfire seasons. An increased frequency of large wildfires may lead to changes in forest composition and reduced tree densities. The greatest increase was observed in the Northern Rockies forest. The Northern Rockies account for 60% of the increase in large fires. Earlier snowmelt dates correspond to increased wildfire frequency as well, with 56% of wildfires occurring in early snowmelt years, while only 11% of wildfires occur in late snowmelt years. Fire risks are strongly associated with increased spring and summer temperatures, as well as earlier spring snowmelt. Since 1986, the wildfire frequency was 4 times the average, and the area burned was more than 6.5 times greater. The average wildfire season has also increased by 78 days. Increased wildfire frequency has been concentrated between 1,680 and 2,590 meters in elevation.
Increased wildfire activity is representative of an environment's response to climate change. This was found due to the connection between warm spring and long dry seasons that were occupied by frequent disruptive fires. And this will become more prominent in the western United States over the next few decades. Land use is also an important factor in increased wildfire activity, and this is found most prominently in mixed conifer forest. The northwestern Rockies and mountains in the west are the most primarily affected areas. These forests face changes in forest composition, and they are responsible for 20 to 40% of carbon sequestration. If these trends continue, there will be increased levels of atmospheric carbon dioxide, and this can have a great impact on the quality of human life, and this will also harm ecosystems. Overall, we see that this study helps people to understand the relationship between climate change and increased wildfires, and helps people to effectively plan for stopping or slowing this down.
Fires have increased in length and frequency over the years due to regional warming, and this has been the strongest in mid-elevation forests, specifically in the northern Rockies. Escalating fires are putting local communities at very high risk of danger and loss of homes, such as what is happening in California, and these fires are affecting local and global communities, so both are needed to help this. This problem needs not only local management to fix it, but a broader understanding and knowledge of the effect that climate change is having on wildfires. The increase in wildfires is ultimately accelerating global warming due to earlier spring snowmelt and drier, hotter summers. If wildfire frequency continues to increase, it begins to put forests at risk of becoming carbon sources instead of carbon sinks. This means that they would be releasing more CO2 instead of absorbing carbon, ultimately fueling more fires and hurting our atmosphere.